So let's kind of talk about this one a little bit. So partial fractions are essentially partial fractions will unfortunately haunt you through the rest of your mathematical specialist maths journey, and it's used when we're working with rational functions, so i.e. when we have quotient of two things. So when we have q of x over p of x, right? And we can kind of decompose the partial fractions from there. So what we want to do here is, for example, if we had something like this, we want to find different methods on actually how we're going to do that, right? Because we've gone from here to here, and this in fact is definitely the correct decomposition, but we want to know how we actually got from here to here, right? So a good thing to learn how to do early is partial fractions. It comes up really important when you go into next year when you're doing calculus. It also comes up importantly when you're trying to graph rational functions as well, because by decomposing it, you can kind of see the different relations and different equations. Because even though this might not be that easy to graph, right, because it's two different functions basically put together, this is even harder to graph in my opinion. So by composing it like this instead, we can kind of see the different things that's going on compared to this where everything's kind of just muddled all together. So in terms of partial fractions, the first thing that we need to do is look at its denominator and then look at the factors, right? So we need to do a bit of magical long division or short division or synthetic division. We just need to do some sort of division to really factorize our factors that we have. And then we can use these rules. And I would recommend having these rules somewhere in your bound notes, just basically anywhere in your bound notes, but just to have at least one copy of this. There's a lot of resources floating around which have like this in different tables essentially. So my best recommendation is choose the table which looks the prettiest and easiest read to you, and just use that table and make sure to have it in your notes somewhere. And in fact, you can use this table if it's pretty enough for you as well. So how I like to think of partial fractions is a little bit of a jigsaw puzzle. So what you're doing is kind of just putting everything together into a puzzle. So if you have just a linear x factor by itself, you can pop one of those in. If you have a repeated linear factor, you can kind of add that onto the end. And then if you have a quadratic, you can kind of add that onto the end as well. So if we had something which was like 1 over x squared plus x plus 1, which we know is an irreducible quadratic because b squared minus 4ac, so that's going to be 1 minus 4, so it's going to be irreducible because it's smaller than 0. Let's say we had x plus 1 squared, and then we had x plus 2. So let's say we had something like that. So if we wanted to decompose it, we know we have a linear factor, so we can start by chucking that in there. So x plus 2. We also have a repeated linear factor as well, so we're going to say that's b over x plus 1, and then we're going to repeat it as many times as we need to kind of get to the equation. So that's squared, and then we add the quadratic on as well because that's another one of the factors. So the funky thing about quadratic is dx plus e rather than just like a or b, just like a single letter. It's dx plus e. How I like to think of it is that always the denominator is going to be one more power than the numerator in these partial fraction type things. Okay, cool. So then we'll have that's going to be over x squared plus x plus 1. Okay, amazing. Alright. So let's try and decompose this one. So I'll pop this one into the chat and give you maybe 20 seconds or 10 seconds to kind of consider what we need to do here. So I'll just give you maybe 10 seconds to have a little, or 20 seconds, let's say, to have a bit of a think. Cool, awesome. All right. So we can kind of see what's happening here. So the first thing that we want to do is decompose the kind of the denominator. So we'll have this is going to be 10t squared plus 13t minus 3. We can do a bit of cross multiplication or try and figure out what's going on. So we know that the factors have to times to kind of give us 30. So the front two have to times to give us 10, and the back two have to time to give us 3, and the middle part has to be 13. So we can kind of break this up into 10t squared, let's say minus 2t, and then we'll say plus 15t minus 3. So if we break it up like that, we can take away 2t at the front of this one, which will leave us 5t. Oh, that's very squished together. So that will leave us with, so if we take out 2t, that will leave us with 5t minus 1 plus, if we remove 3 from there, that will also give us 5t minus 1. So then if we group the things together, that will give us 2t plus 3 and 5t minus 1. Okay, so essentially now we have 8 minus 3t over 2t plus 3 and 5t minus 1. So hopefully we were able, so if we looked at this, we can identify that we need, two linear factors. So we'll have a over 2t plus 3 plus b over 5t minus 1. Okay, so then we times everything across, so we get 8 minus 3t will equal to a 5t minus 1 plus b 2t plus 3. And the best thing to do here is that we need to look into, so there's kind of two methods of figuring out the actual values of them. So the first method is like simultaneous stuff. So the first method is simultaneous. So what we do is we'll get 8 minus 3t will equal to, and then we kind of group. So we'll have t 5a plus 2b. And then we'll have the normal part of it. So we'll say plus negative a plus 3b. And we equate those coefficients across. So we'll have 5a plus 2b will equal to negative 3, and negative a plus 3b will equal to 8. And then we can kind of do simultaneous equations on those two. Alternatively, the other method is we sub values in. So you sub in the values for what you're going to get here. So if I subbed in 1/5, right? T equals to 1/5. T equals to 1/5 would cancel out what that part is. So I would just get 8 minus 3 over 5 would be equivalent to b times 2 over 5 plus 3, right? So 8 over 5, that's going to be 40. 40 over 5 minus 3 is 37 over 5. And our b component is going to be, so that's 15. So that's going to be 17b over 5. So we're going to get that, when we try and cancel that out, we'll get that b is going to be equal to 37 over 17, which is a bit of a gross number, but can't really be done. And if we tried to do the same thing here, we could multiply the bottom equation by 5, so we end up with 5a plus 2b equals to negative 3, and negative 5a plus 15b would equal to 40, right? So when we times everything across, then we'll get the same thing. So we'll get 17b will equal to 37. And that's what you can get there. And then we can, so for this, once we do that, there's benefits to both, right? Because then once you sub it, you can just directly sub it into here to get what you want. And then for this one, we would have to sub in t equals to negative 3 over 2, right? To get rid of this one. So that we only end up with the a component now. So then now we're going to get that 8 plus 9 over 2 will equal to negative a times negative, let's rub out so we have more space. Let's just erase all. So so far we've gotten that, let's just write our equation one more time. So that's 5t minus 1 2t plus 3. We said that's equivalent to a over 2t plus 3 plus b over 5t minus 1. So we got 8 minus 3t is equivalent to a 5t minus 1 plus b 2t minus 3 plus 3, sorry. So we've gotten so far that b equals to, I think it was 37 over 17. Yeah, I think so. So that was 37 because that would have been positive. That would have been, yeah, so it's positive. And then we get our a component. So we're subbing in 2/3 before. So 2/3 here would be, oh sorry, 3 halves, negative 3 halves here. So we're subbing in t equals to negative 3 over 2. And we'll get that this side equals to 8 plus 9 over 2. And the other side equals to a times negative 15 over 2 minus 1, right? So we'll get that this is, so that's 16 over 2. So we'll get this is going to be 27 over 2. Oh no, not 16. So yeah, so 25 over 2. So we get 16 plus 9, so 25 over 2. And that's going to be equivalent to negative 17 over 2. So we kind of can take out the 2's, but then we'll just get that a will equal to 25 over negative 17. And in the previous one, we got that negative a plus 3b would have equaled to 8. So we can kind of, we already knew what b was, so we could have substituted it into there. So we get negative a plus 3b, which is 100, and so that's 21 times that, so 21 plus 90, so 111 over 17 equals to 8. So when we kind of put that across, so when we times 17 by that, we'll get that 7 times that is 56, and 8 times that is going to be, so 8 times that is going to be 80, so 80 plus 56 is 136, so 136, so we'll get that negative a equals to 136 minus 111 over 17, which means that a would have equaled to negative 25 over 17, like this one suggested. So there's kind of two different methods. So this is the subbing method, and this is kind of the elimination simultaneous equation method. Cool. Alright, so let's chat about this one a little bit more as well. So this one is, once again, our partial fractions, and what we're trying to do first is we want to kind of expand the denominator, or more factorize the denominator until we can get something where we've decomposed it all into our factors. So our x cubed plus 9x is going to be equivalent to x squared plus 9. If we check the discriminant of that, that's going to be 0 minus 36, so it's smaller than 0. So therefore we can kind of move on from there. So we'll get that this is 2x plus 4 over x cubed plus 9x. And a gimmick here, I guess, is that this is actually bigger than this, right? So we actually can't turn it into a partial fraction straight away. So what we need to do first is, because this value is going to be bigger than this, it's going to turn into an improper function if we try to do it straight away, and it's not going to work out terribly well. So, and also it's going to make it hard to kind of equate coefficients and do that. So what we can do first is kind of just divide across first and do a bit of long division. So we'll have x cubed plus 9x, and we'll have x to the power 4 plus 0x to the power 3 plus 0x to the power 2 plus 0x, and then just plus 2 at the end. So we can put that in, and we'll get that this is going to be x, right? And so this is going to be x to the power 4, and we're going to say plus 0x cubed plus 9x squared, and that's going to be just negative 9x squared plus 2, essentially. So if we look at that, that can't divide into it anymore, so that's the new thing that we're actually going to get. So this is going to just be equivalent to x plus negative 9x squared plus 2 all over x cubed plus 9x. So this is the thing that we're actually going to decompose. So when we try and decompose that component, we'll get that negative 9x squared plus 2 over x squared plus 9 will be equivalent to a over our x plus b x plus c over our x squared plus 9. So then if we kind of times across and make sure everything's times across, we'll get 9x squared plus 2 will be equivalent to ax squared plus 9 plus x bx plus c. Alright, so then we can, once again, we can either equate coefficients or sub in values. Either way is fine, essentially. So maybe we can try both ways just to kind of go over it one more time. So let's maybe do it via the simultaneous equation version first, and then we can go through together and we can pick up from this step and do it via the subbing values. So if we do it simultaneously, we'll get that negative 9 will be equivalent to a plus b, right? Because we'll have ax squared and then plus bx squared. And we'll have that 9a will equal to 2, right? And c will equal just to 0 because we can't see any c's. No pun intended, because there's no x component on that side. So we'll get that a is actually just going to be 2 over 9. So b, therefore, when we kind of put that across, because that's negative 81 over 9, so that will be, b will be negative 83 over 9. Cool. We can try doing the substitution method up here. So we can sub values in. So if we subbed in x equals to 0, this part would be cancelled out, right? And we would just get 9a would equal to 2, right? So therefore a would equal to 2 over 9. And then what we can do after that is try subbing just different values. So now x equals to 1. And we would get that this is going to be negative 9 plus 2, which is 7, is equivalent to, so we know this is 2 over 9 out here, and we have 1 plus 9, so that's going to be 10, so that's going to be 20 over 9, and then here we're just going to sub everything 1, 1, so plus b plus c, and then from here we can also do x equals to negative 1, right? And that would give you the same thing on that side, right? 7, and would give you the same thing here, so that would be equals to 20 over 9. That would be negative, so we'll have minus c minus b, so we'll have just b minus c then, plus b minus c. So if we added those two together, we would have gotten that 40 over 9 plus 2b, because the c's would have cancelled out. And then when we kind of just move that onto the other side, so we want to find out exactly what b is. So when we kind of move that to the other side, we'll get that b is a certain value, so we can put that across. So it will be 20 over 9, and then so 40 over 9, we can kind of divide that across and times that across, and we'll eventually get an answer from there as well. So you can kind of see how the two different methods work out. But essentially it's up to you for either. To be very honest, a couple of these questions, I feel like the numbers are a bit gross, but you know, if the numbers were a bit nicer, be a bit more straightforward. But I guess you can get gross numbers as well, so fair enough. Alright.